All right, so in example 4, we are going to graph a piecewise function, and there are clearly 4 parts. So again, the first thing I'm going to do is I am going to highlight my boundaries and where the functions switch over. So what I notice here is the first section goes from -4 to -2. It does not just go to an end, it is strictly between -4 and -2. The next one goes from -2 to 0. And then I've got 0 to 2. And then I've got 2 to 4. So what you can see here is that my function is only between these lines. It does not go outside of these. So I've got 4 different parts. In the first section between 4 and 2, I have the function 2. In the next section, I have the function between -2 and 0, I have 5. In the next one, I have 7 between 0 and 2. And in the next one, between 2 and 4, I have 10. So what I know here is these are all constant functions, and I can already tell this is going to end up being a step function. So I can connect these at their respective level. And now I have to figure out what's going to be open and closed on the end. So I'm going to definitely have circles on either side of these. But I have to look back at the function to know which ones are closed. Right now I have them all open. That's how I like to start. So now this one says from -4 to -2. And the -2 has the equal sign on it. So that means this side is going to be filled in. -2 is open, 0 is closed. So this side's going to be closed. And the 2 is closed, and then also the 4 is closed. So there I have my graph. I'm looking carefully at what's open and what's closed. I know that I cannot have one value with 2 closed circles. So it makes sense that this one is closed and this one is open. If you had 2 closed, it would not be a function because it would not pass the vertical line test. So now the domain's a little bit different in this one. Like I said, it only goes from -4 to 4 in the x values. So I know it goes from -4 to 4. Now I also can see at -4, I have an open circle. So that one is going to be a parenthesis. At 4, I have that closed circle. That one is going to be a bracket. The other way you can write this is -4 is less than x is less than or equal to 4. Remember, domain is my x value. So I'm just looking at how it does left to right. My range is my y values. The only thing in my range here is just 2, 5, 7, and 10. So now, similar to when we were writing the domain and range of a step function in the writing of piecewise functions, I'm using set notation here, and I just have 2, 5, 7, and 10. And as step functions normally are, I cannot trace this without picking up my pen. That makes it not continuous. And now what we haven't done yet in these videos is evaluating. So if I'm looking for f of -4, remember this is my x value. If I'm looking for f of -4, here's -4. Notice I have this open circle. That does not mean that the value of f of -4 is 2. It means that there is no value of f of -4. So if you're looking for f of -4, you actually have no solution. Maybe it's undefined. I'm just going to leave it at no solution for right now. If I'm looking for f of 0, here's 0. And notice I have 2 dots that fall on x equals 0. I'm looking at the filled in circle. So notice here, this is where x equals 0. It would fall under this category, not this one, because this is just where x is greater than 0. So the value of f of 0 is going to be 5. And then the last one is f of 3. So 3 falls between 2 and 4. So that one's going to fall into this category. That's going to be 10. If I look at the graph, here's 3. The value at 3 is 10.